Okay, for this lesson we're going to be looking at how we learned completing the square process in a previous lesson and how we can use that to actually solve quadratic equations. Now, if we think back to previous lessons on quadratic equations, we came up with many methods on how to do this, and if we have a quick review of solving quadratics, we'll remember that graphing was one way, and we could just get the visual understanding of what the x-intercepts were, and those were the solutions. And as we all know, that the visual solution was not always as easy to determine, and so we needed some mathematical ways. And the first mathematical way was factoring. Then we moved into square roots, and of course underneath square roots we ran into imaginary numbers for the first time. And so what happens is, as you move along in quadratics, factoring does not always work for every single quadratic. Square roots only work for quadratics that have no bx term or no middle term. And so every now and then you're going to end up with a quadratic function that, or a quadratic equation that has a middle term for bx but is not factorable. And so that's when we need to look towards completing the square as a process to help us solve the quadratics. So very important that you know all of these different methods of solving quadratics for the unit test, and it's also extremely important for you to know when to use each of these quadratics as you see different types of problems come up. So let's go back and look at a way that we can use completing this square as a method for solving quadratics. Now, if you notice this, completing the square actually is a method for solving any quadratic, whether it has a bx term or not. Completing the square will actually work. So if we look at example number 2, solve x squared plus 10x minus 3 equals 0 by completing the square. What we technically want to do is we want to create some space to actually complete the square. So the first thing we're going to do is we're going to add the 3 to both sides, and then we're going to complete a little space here to go through and solve for our c value. And if you remember, that was b over 2 squared. In this case, b was equal to 10. So 10 over 2 squared equals to 5 squared, which equals to 25. So you can see this calculation there helps you complete the square. Now notice, we elected not to change this number to 25 because, if you remember, whatever value the b squared represents, b over 2 squared represents, the b over 2 value actually goes in place of our square of a binomial. Now, this is where we want to get to in the completing the square process. So we want to physically create a perfect square trinomial. Then we want to, in this case, our perfect square trinomial we completed right there. And then we change that perfect square trinomial to a square of a binomial. Now, the whole reason that we did this was simply so that we could take square roots from each side. So we're actually using the completing the square process to make it easier for us to take a square root in the long run. And then if you notice, when we take the square root of both sides, the remainder of this problem just looks like a square root problem that we've worked before back in a previous lesson. So we would take the radical of square root of 28 plus or minus, and then of course we would subtract 5 from both sides, And of course, when we subtract 5 from both sides, it's extremely important that it goes in front of that plus or minus so that we write this number in the proper form. So let's take a time to try to do this process on our own. So what I want to do is look at a couple sample problems. So I have sample problem number 2 and sample problem number 3. Now both of them have a little bit of a difference of issue in there. So what I would like you to do is to right now try to work sample problem number 2 first, then watch the solution to make sure that you're doing the completing the square process correct, and then move on to sample problem 3. So go ahead and work sample problem 2 right now, and I'll show you the solution in a sec. Okay. So as we're looking at this, I'm going to show you how I like to set these up with spacing and things of that nature. We should be able to look at x squared plus 6x minus 8 equals 0 and see that x squared plus 6x minus 8 is not factorable. Now I know it looks like it would be with 4 times 2 equaling to 8, but the negative in front of the 8 really messes things up, because if I have a negative 4 plus 2, I can't get to 6, and if I have a positive 4 and a negative 2, I can't get to 6 as well. So it kind of creates some problems there. So what we need to do is we need to move the negative 8 out of the way. So what we're going to do is we're going to actually add 8 to both sides. And we're going to get x squared plus 6x equals to 8. Now, what I've done here is I've actually intentionally left some space so that I can do the completing the square process. So I'm actually going to have to add something to this x squared plus 6x to complete the square. Now, if you remember the golden rule of algebra, whatever we do to one side, we have to do that same operation to the other side. Now, if x squared plus 6x is missing the c value, which is at blank, we need to find it. And so that's going to be the b value over 2 squared. In this case, the b value is 6 over 2 squared, which is going to give us 3 squared, which is going to equal to 9. So we're going to add 9 to both sides. Now, the number that we really want to look for here is this positive 3. Now, x squared plus 6x plus 9 is a perfect square trinomial. And of course, you should know how to factor that perfect square trinomial at this case. So you could go ahead and factor x squared plus 6x plus 9, but what we're hoping that you'll do is you'll skip right over that step and recognize that this is x plus 3, which is that highlighted number, squared, because this is going to be x plus 3 and x plus 3. And that's going to equal to 8 plus 9, which is 17. Now, what we've done in essence here is we've created a square root problem. And you've seen some of these in previous notes. You've seen square root problems like this in class, and you've also seen square root problems like this on previous assessments. So this should be comfortable for you at this point. So what we'll do is we'll take the square root of both sides, and of course that eliminates the square, which gives me x plus 3 equals to plus or minus the square root of 17. And then I have to subtract 3 from both sides, and so we're going to put that negative 3 in front of the plus or minus. And since the square root of 17 cannot be simplified, this gives me my 2 solutions of the quadratic equation. Now, what I would like you to do is to go ahead and work sample problem 3, which brings into account another issue. I want to see if you can figure that out and then go through the completing the square process again. So go ahead and work on sample problem 3 right now and come back and watch the solution when you're finished. Okay. If you're looking at sample problem 3, you should recognize one major problem here. If the completing the square process is a process that helps us create perfect square trinomials, we're going to struggle to create a perfect square trinomial with 5x squared as our leading term because 5 is not a perfect square. So what we told you to do in looking at any quadratic function, especially if you're thinking of factoring as a method of solving, is to look for a common monomial that could be factored out. And in this case, we have a common 5. And of course, when we're solving quadratics, the single factor, a numerical factor, not only can be factored out, but it can be divided out, which gives us a much easier term to work with. So in this case, we're going to be x squared minus 2x plus 6 is equal to 0. And so we get a trinomial, basic trinomial. Now, x squared is a perfect square, but 6 is not a perfect square, so we technically need to move that out of there. So we're going to subtract 6 from both sides. But of course, I'm going to leave some space there. And I'm going to get negative 6 over here. Now, I like to give myself these visual clues with these blanks, so I'm reminding myself that I'm going to be completing the square here. And on the left side, I'm going to try to create a perfect square trinomial. So in order to create the perfect square trinomial, we need a c value, which is going to be b over 2 squared. And of course, in this case, the b value is negative 2, which gives me negative 1. Make sure you leave that in parentheses because negative 1 squared is a positive 1. So we're going to add 1 to both sides. Now, we have created a perfect square trinomial on the left side, which at this point I'm hoping you're recognizing is it's going to change into the square of a binomial using the negative 1 value. So we're going to have x minus 1 squared equals to a negative 5. Now we've changed it to a square of a binomial, which allows us to take square roots. So we'll take the square root of both sides. I'm left with x minus 1 equals plus or minus the square root of negative 5. Now, we need to add 1 to both sides, and of course it's very important that I put that in front of the plus or minus. Now, the other issue that we've got to deal with is to simplify the radical. And if you notice, we have a negative number under the square root, and of course, anytime we see a negative number under the square root, we should recognize that the I term is just going to be factored out, or excuse me, simplified out. And so then we now have a complex number as our answer. So 1 plus or minus I times the square root of 5 gives us both solutions. So that is the examples of using the completing the square process to help us solve quadratic equations. So you can see that the completing the square process goes through a couple of things. First, you have to make a perfect square trinomial, take that perfect square trinomial and rewrite it as a square of a binomial. Once you have a square of the binomial, you can then solve the rest of the quadratic by taking square roots and come up with your final solutions. So that is the end of this particular lesson. In the next particular lesson, we'll tell you how to rewrite the form of a quadratic function.